My name is Daniel. I'm also from Romania. And I will talk about high school projects with kids in the CoderDojo network. So, oops, let me. What about I will talk today? Who we are. I don't know how much of you are familiar with the CoderDojo network. Are among you some who heard about CoderDojo? It started in Ireland in 2011. It's a network of volunteer-led programming clubs in more than 75 countries, serving more than 10,000 kids. So, we started our CoderDojo in Oradea 8 years ago. And the mission was to provide the kids hands-on experience in coding with projects, something that in high school they are not getting. So the goal was to be able to found a place where the kids can work together and share their knowledge and find meanings in that programming that they are learning. So Oradea is from the western part of the country, and after 4 years, we made the spin-off from the CoderDojo, which is called CoderDojo Oradea Space Robotics. I have a background in astrophysics and mathematics, and I am the mentor of the team. And I thought at that time that giving them some purpose, some motivation, some competitions to participate will engage them more in what they are doing. So, sorry. CoderDojo Oradea Space Robotics, abbreviated as CDOSR. We started with projects in AstroPy. Then we shifted to Erzse, which is a competition held by the Romanian Space Agency, CANSATs, and more other robotic competitions. Actually, we participated in the last 4 years in the national CANSAT competition, and we won it 2 times. We started in 2018 with our first participation in Erzse. It's a competition about space rovers. Was our first participation. The team didn't thought that we can win. We won it. That motivated them, and they decided to participate in our first CANSAT competition. So since then, we had 2 titles in CANSAT, national CANSAT. We participated in 2019 in the SS European finals. Unfortunately, we got our satellite, but was not fully tested for rocket launching. In our country, the launching is by helicopter, dropping by helicopter. So our sensor stopped at 30G acceleration. So we had data only before the launch and after the satellites descended. The next competitions, which in this picture you can see, it's a rover. We won Erzse, which is the Romanian Space Agency's rover competition 2 times, the last 2 editions, building a 6-wheeled robot, which was remotely operated from Oradea. The rover was in Bucharest at 16 kilometers away. That was last year. Because of COVID restrictions, we couldn't participate. The competition was held in a hybrid form, so the teams were at their home, and the mission was to remotely operate these rovers. So after some CANSAT competitions and some rover experiences, I'm also an advisor at ROSPIN. ROSPIN is the Romanian Space Initiative, an ecosystem which tries to we can say to develop various activities such competitions, educational programs for enhancing the space community in Romania. And talking with them, we decided to give our kids an opportunity and we moved towards PocketQubes. Why PocketQubes? Actually, the last 4 editions of the CANSAT we participated. The CANSAT competition have a rule that says that in each edition, only 1 member from the last edition can participate. So all these kids, after developing their satellites, are not able to participate again. But they are gaining knowledge and experience, and they wanted something more. In the last 3 editions, we built our custom PCBs for the CANSATs. So they thought that a CANSAT being 66 millimeters wide and 110 millimeters length, why not try something smaller? Why not try? Some of them are already students at universities. So for them, this CubeSat seems appealing. And we started to think about something we can use as an educational purpose, because CoderDojo means teaching kids different skills, computing skills, robotic skills, programming skills, engineering skills. So we thought that let's dip into this and try to build a satellite. Initially, it was a CubeSat. 2 years ago, we thought about the CubeSat. But after hearing about PocketQubes, and because we are already miniaturized our CANSATs, we decided to prototype a CANSAT. This is a prototype. I have the PCBs because we received the PCBs from GSE PCB only 3 weeks ago. Actually, only the EPS board you will show later is already built. So we thought about a modular PocketQube, and we are thinking it as a hands-on learning tool for research and data collection, maybe for remote sensing and imaging, and for satellite communication. These are intended purposes. Sorry. So as a hands-on learning tool, we think that students can design, build, and launch their own PocketQube satellite, providing them with hands-on experience. We can integrate them into STEM activities, space-related curriculums, because as Katalin mentioned before, space-related curriculum is missing from Romanian high school. And allowing them to conduct experiments, maybe to gather data in space in the future. For research and data collection, the satellite can enable students to participate in experiments collecting data on various topics: atmospheric conditions, environmental changes, geological phenomena. Additionally, maybe they could integrate some camera and capture images if we achieve that point and that it will be launched. This whole project started as an educational project. What we are developing here has no solar power, so it has antenna radio communication capabilities, but it's only as antenna connection. There's not having an antenna. It's not intended as for flying up in the sky. So it's only modular design for kids, for trying to produce them and distribute them to clubs. We started thinking about CoderDojo clubs first, maybe for high school if they are interested. Remote sensing also, the satellite's size and low cost, it's making it ideal for remote sensing and imaging applications. Furthermore, satellite can observe weather. It can be built as a weather station. I mentioned that it's an educational project, not CubeSat. It's in a form of CubeSat and may develop as a CubeSat in the future. Networking and satellite communication. I mean, on the 3 modules we started to develop with the kids, they are radio. We are using LoRa for radio communications, and they can experiment some so effects of radiation or communication or navigational system in space in future, but it is an easy hands-on application for radio communication. Sorry. Okay. So how it looks like. Here we have the electrical power system. So the electrical power system is a 4-layer PCB, double-sided. On this side, we have a Cortex-M0 processor. It regulates the power output and distribution. Monitors, we have an integrated circuit for monitoring the power level usages. It has its own memory. Can store the data about the memory consumption and the parameters, for the power consumption and power parameters. This is the lower the downside of the PCB. Here we have an SD card which can store the data. So we have kind of double system, memory, flash memory. Because it has a USB port, it can be accessed if it's connected to a computer as a USB host and can read from the flash memory, but it saves its data on the SD card. It operates, as I told, that it's not having solar power and not having batteries as it was designed now, as it is designed now. It works if it's connected on USB port or if it's connected to an external power source, and for this reason we have a switching regulator and then a LDO to step down the voltage to 3.3. So the onboard computer, it's also having its own microcontroller chip, its own memory. We have connectors for additional I2C modules. It has temperature sensors, environmental sensors. So, for example, in the upper right, the white one is BMP688 from Bosch. We have ENS 160 for environmental sensor. We have the possibility to connect other sensors. That's why I thought it's for testing and for experimenting with kids. It also has USB port, so this port theoretically can work as a standalone board. The communication board. On the communication board, we have a Quectel GPS, and with the big black rectangle is actually the small battery holder. And we have a radio module, LoRa radio module, and also connectors for I2C buses. I didn't mention that we have, for redundancy, we are using two I2C buses. Sensors, temperature sensors, and environmental sensors are connected for each I2C bus. So it gives the possibility to attach and test other I2C components. Okay. As an educational project, two things are important. Affordability and accessibility is one. Making a project affordable means that we need to ensure that it's not too costly and it's available to most of the kids. So we are using low-cost materials. We are buying mostly SMD components from Mouser and TME. And since we are prototyping and developing our circuits, we are playing with those. And the second one is versatility. We are thinking as a modular system. For example, for the EPS board and for the OBC, we are trying to build different variants and testing them with the kids to see what. Actually, it's a double system. We are testing things on CAN sets and using it in this one, and are testing separately components on this PocketQube and using maybe in the next CAN sets, because the main activity remains the CAN set for us. The kids are crazy about the possibility to participate. We have our record of winning 2 times. They hoped this year they won again. It didn't materialize, so they are hoping for the next year. Okay, and future work. We can see that I don't know in which direction we will go these are only some points we are thinking to deep in, maybe an attitude in ADCS, if it's possible. But again, these kids about I am talking are high school kids. Some of them are geniuses. One of them has an older brother which is a master's at Delft University. So, so the youngest brother is passionate about astronomy, and think about it, he is 14 old. He built himself a Kalman filter for his telescope. So they are not too many kids, but they are bright and smart. And we at CoderDojo or other space robotics are trying to give them some opportunities to learn things and maybe in the future use it. So we are thinking to build data dashboards with the students. We have web group. We try to integrate these kind of groups. We have Unity group. We have Python group. We have C++ group. So this one I'm talking about is the one that is interested, those kids that are interested in space-related activities. So we are trying to give mixed activities and maybe use some of them to build the data dashboards. So maybe, I don't know, in 2, 3, 4 years, we will see what direction this PocketQube initiative goes. Maybe to build one that can be launched. And also, we are planning on to conduct educational programs with them, and I hope the future will be bright for them. Thank you very much. If you have questions.